Hello, welcome to my Zoom room featuring a plant and Snoopy. My name is Sam Cartford. I work as a technical analyst at Boom Lab. I do cybersecurity by day. My meantime, I love working on NLP kind of projects, and we have one of them here. So if anyone is out there and has some experience, maybe has heard of GPT-3 or other, recent advancements in natural language processing, I would love to hear what kind of audience is out there and who I should be, talking to. Should we look at, some of the basics or some of the more beyond stuff? But I kind of recently started seeing some of the output of GPT-3 and wondering, how does it start and how is it so good? And the following question is, why isn't it bad? Because it's really easy to generate text that makes no sense, because we as humans have a really good understanding of the second that language doesn't seem quite right, we have a very immediate reaction to that. And we'll see some of that bad text today. First, let's look at some stuff from GPT-3. So some of the output, and pardon the language in there. The first thing on the left, all the things in bold were an input into this big crazy network. And everything beyond that by Dr. Seuss line is generated by a program. So it's uncannily good. And especially when it comes to the fact that it's able to rhyme and create a poem and recognize the structure and do it in like the Dr. Seuss kind of language, speaks to the genius of it all. On the right, we'll see the top lines are inputs and the bottom lines are censored. Maybe help some of your coworkers out this way. But GPT-3 will do a good job of, cleaning up language and making it more helpful and less evil and mean. And one of the main problems is we see the output of it, but there's not really any indication of where it comes from. It's trained on so much language that we don't really know exactly what line it's coming from. So, what is GPT-3 right now? A company called OpenAI spent $4.6 million training this giant network, bigger than anything that's ever existed. And now they're selling licenses for $100 a month, and we see that just doesn't make much sense for anyone else to try to recreate, because it's so big. And it's trained on essentially the entire internet. But what can we do from home? Let's see. When we look at ways that we could generate text, think about a favorite book of yours and how you might go about pulling text out of that, and how you might be able to recreate the style of that author, and what if that is easy to do and what kind of necessitates a human. Because we in these words are much better at understanding them than things that are just treating them as data points. So we could think about maybe pulling out the most common sentence in that data, where the training data here is just that book that you're thinking of. Could we use grammar to be a little better? What are Markov chains, and can we use those? And can we beat the initial attempt at Markov chains? And then, I don't have anything prepped for you guys today, but the encoder and decoder architecture is what's used more generally for this task in production by people who are a little better at it than me. So with that in mind, hopefully it's okay with you guys if we look at my terminal. We'll do some coding, do it live. So what we're doing is pulling text data from a thing called Project Gutenberg, which is really just a bunch of plain text books that they host and give out for free. So we can pull in some classics, and we can use these and kind of test to see what looks like good data that we generate from that and what doesn't. So if anybody out there could take a second and pick from these which ones we'd like to start playing around with. By the end, we'll try to do it with each of the books to see if we can recreate the style of the author. But any preferences on which books we should try? We have Pride and Prejudice, Frankenstein, Christmas Carol, Sherlock Holmes, and Huck Finn. Anybody? Otherwise, I guess we can try a little bit with each. Let's look at, get rid of these lines. What is the most common, or what are the most common sentences of How About a Christmas Carol? Let's try Pride and Prejudice. I agree. And what we see is it'll spit back a dictionary. After going through and pulling all of these different texts, it'll give us back a dictionary. This. The most common sentences that we see throughout the entire book, which, as we'll kind of tell, runs into some problems with the way that we tokenize and look at language, because even we aren't very good at it. So it's running. And the only sentences that come back, more than 5 times are these short sentences that get recognized as sentences, but they're really not, which kind of points to the fact that most language that we actually say every day is unique. Most times, every day for sure, you say at least one sentence that has never been said before. And there's also a pretty good chance that the average sentence hasn't been said before. So when we look at these kind of text generation models and we don't have a good way of generating the perfect sentence for a scenario, of course we're going to get this kind of spotty feedback. But the next question is, if human language follows grammar, which they all do, can we use that to get back some more information about what we can do to make sentences that look good and sound more real? So what we'll do is we'll get the most common patterns from Pride and Prejudice. Ooh, zoom in a little. Let's see. There we go. My laptop is very upset at me today. However, yeah, we can. It's not working. I'm sorry, guys. Okay. Be able to get back the most common grammatical patterns out of Pride and Prejudice, which should help us to generate language that looks a little more like something that actually exists. So when you think about grammatical patterns, it's more than just nouns, adverbs, adjectives, and what have you. It's the way that they work together. Authors can convey style even through the grammatical patterns, as that's actually how they found out. If you know Alexander Hamilton, the musical, Hamilton wrote the other 51. We figured that out by looking into the grammar patterns and the words that were used in those 51 out of the original Federalist Papers. And using that information, we were able to tell who each individual author was. And so we see a bunch of stuff that doesn't mean a whole lot, but these are the ways that the author is conveying their sentences. So we can take an example of just one of these, which is 2 proper nouns. 3 proper nouns an hour. Yep. So we'll go here. And we can try out a few of these, but we'll run through. What it's going to do is run through, try to grab each proper noun, each of these for each tag, and then we're going to grab the most common of each of those and build that into a sentence. Type in Pride and Prejudice. This. We'll see the first thing that hopefully starts to look like an actual sentence. We could, of course, make these up for any sentence that you might have in mind. Any common grammatical categories. Initially, I was going to run this on a web demo. Sorry, guys, it didn't really want to work on my laptop today. Nice, a sentence. It looks more like a thing that people would actually say. It still isn't coherently saying anything in particular, but it at least mimics actual language. We can do another example would be, we can give it someone's possessive adjective noun. And we'll see what kind of language exists inside Pride and Prejudice that might look like this. After this, we'll get into what's called a Markov chain. And Markov chains have been used to backtest on someone's tweets. Someone in particular that's been tested a lot on is Donald Trump's tweets have been a way that people have attempted to see if they can generate language that comes from a certain distinct style. And so, yeah, again, these are words that came out of there. The sentence doesn't exist inside of the text that it came from, but it does look almost readable. So what we'll do next is we'll go on to Markov chain. Let's see if we remember what it's called. Okay. A sample sentence, Pride and Prejudice. We'll give it a sentence length of, let's say, 25 words. We'll get back. So if you think about a short sentence like, my name is Sam. Sam likes sweet potatoes, which is true. What you realize is certain words tend to follow more of the other words. So what this Markov chain will do is look at the word name follows the word my. So every word that is before name will get added to a list. And then each time that we want to go to generate the next word, we'll look at whatever words statistically tend to follow the word name, and we'll put that in here. So if we were going to make a Markov chain of this sentence and we started at name, we're definitely going to end up with the word is. But if we start with the word Sam, we'll add another word, my name. If we start with the word Sam, we're 50% of the time going to get Cartford back, and 50% of the time going to get likes. So when you add this up over the course of an entire book, you actually start to see that we can follow sentences in a way that makes a lot of sense, and they actually seem publishable. You can't quite get to article length, but you can make stuff tweet length. We must go, and facing the moment is the depot. He began to retain or go at the Williamsport, and that he replied something, and we may never know. And again, now we're starting to get dangerous, because this is a sentence that we read as making sense. And it doesn't exist in the text, but you can tell it's from the same style. If we were to drop in Christmas Carol, well, let's compare contrast. We'll make two. Look at Christmas Carol. This is randomly generated. We'll get a different sentence back, this time for Pride and Prejudice 2. In the middle, so we know where it's starting and ending. Let's do one with Sherlock Holmes. If anyone is interested, this is up on GitHub, and it will be live on that web server I was talking about. So you'll be able to play around with it at some point if you want. So let's look at what it came out with. And deepen all the savings bank. I know it. So what you would do in practice is you would run this and simply just chop off whatever's on the end and get back sentences that make a lot of sense. The causes of lateral margin of his experiments as regards horsepower was capable of having 14. And so here we can see it's confusing. It doesn't quite make sense of having 14 what. This is where we start to see the huge gap that exists between these simple statistical methods of seeing which words are most likely to follow which other words, and the extreme jump between that and something like GPT-3, where it's trained on so much language that all the sentences at least make sense, and it can carry a consistent theme for an entire article length. Consistent, you know, it does the same thing where it's intro, 3 body paragraphs, and a conclusion. It's about as smart as a high schooler. It's really good. But what we can do to make this better is, instead of looking at each individual word and seeing which words are most likely to follow each, we can use what's called a bigram. And a bigram is basically just chunking up each consecutive group of 2 words and then use those to build that transition matrix, which is going to tell us which bigram is most likely to follow which other bigrams. This is just randomly sampling over all the possible ways to follow out of a sentence or to create a sentence from this. But what we can do instead is use these bigrams and also force it to choose the most likely option. So the language that it's choosing and the word that it's choosing next is going to be the highest probability to have existed in the text, which will be a next step towards making this make a lot of sense. So if we take this out, let's say we want to print a sentence. Again, we'll go with 25 words. And this is The Man That Was Thursday, which is a really good book in case anyone is looking for one. It's actually what Neil Gaiman and Terry Pratchett both loved reading, apparently, while they were writing Good Omens. And I had read it after he tweeted about that. And it was a really good book. So this is the next step smarter. And we see it carries a theme and now makes sense to the point of I could read this and I wouldn't be thrown. This is now basically up to the Turing test of, the version 1 Turing test. A dark string of men and seemed to feel a new impulse to tear it out. He was one of the stage I mixed with. Whoa, it's really good. We can try the same thing. That's again another, you got to read that book. We can try with Huck Finn. See if we get back anything that sounds like I could just, use this to write my own Mark Twain style books and be famous that way. Very simple. So this one needs a seed. Go with first two words need to actually occur in the text. We could also just random sample from one, but if we pick something that definitely exists in the text, it goes a long way in helping this to be a very probable sentence to exist. Unless, of course, it doesn't. Let's do Pride and Prejudice. There's also the chance that I'm just pulling these blindly and I'm not getting the right book. And I know we're getting close to time here, but please reach out afterwards if you have any interest in any of this. Sorry, it was a little scattered. I wish I could have done the web server version of it. But I had a lot of fun making this, and you can have a lot of fun giving it different training data, different books. We could smash all these books together and just feed that in. And it's crazy to see with a few pieces of intuition where we can take this natural language generating statistical process and make it make some sense using that. Pride and Prejudice. And so, I mean, for one final hurrah, we can just make a super long sentence, 150 words. Doesn't really need to make sense, but it's funny to see that stuff. It ends up very nonsensical and funny as it goes. But again, this code will be up on GitHub. You can reach me at cartford@hey.com if you're looking for where that is. And if you just want to play with it yourself, yeah, it's worth it. Come on. Ta-da! One final piece. Well, thanks, everybody. It's been an honor. Definitely reach out. I'll put my email in the chat. Thanks for coming out.